Module 11.4, Woodwind Instruments. The woodwind instrument family comprises wind instruments that produce sound when the player blows across a mouthpiece to create an airstream, or from pulses of air that are produced when the player uses air to cause a reed to vibrate. The mouthpiece or reed is connected to a tube that is made of wood, metal, or plastic. Along the length of the tube are tone holes. Instruments of the woodwind family are the piccolo, flute, recorder, oboe, English horn, clarinet, saxophone, and bassoon. Clarinets and saxophones use a single reed. Oboes, bassoons, and English horns use a double reed. Flutes, piccolos, and recorders do not use reeds. With woodwinds, different notes are played by opening and closing tone holes along the length of the instrument. Tone holes are closed directly by the fingers or by pressing keys which cover the tone holes. The size of the hole affects the effective length of the pipe. The larger the hole, the more it shortens the instrument's effective length. When the diameter of the hole matches the inside diameter, it effectively ends the length of the vibrating air column. Register or octave keys, which cover small holes, have the effect of changing the length of the air column of the reed instrument so they can play in several octaves, while the other holes adjust the reduced length air column. Flutes, piccolos, and recorders do not have register keys. They change octaves by increasing airspeed over the mouthpiece. In general, reeds vibrate at just one frequency, so reed instruments depend on the register keys to increase their range. Saxophones and clarinets can also increase their range by changing their embouchure, how the mouth and lips are adjusted, to squeeze the reed more tightly. This raises the vibrating frequency of the reed, which allows higher harmonics to sound from the instrument. Reed instruments create a pulse wave to excite the instrument's resonances, whereas flutes and recorders use an airstream to create sound. An airstream creates random vibrations, which we refer to as noise. Pulse streams and noise are rich in frequency content, so they are good sources for exciting the resonances of the tube. All woodwind instruments tune by pushing the mouthpiece in or out to adjust the length of the tube. Like all wind instruments, temperature has a large effect on an instrument's tuning. All reed instruments act like tubes closed at one end. Clarinets are mostly cylindrical in shape, and so they have mostly odd harmonics as resonances. The clarinet does have a bell, so there are some even harmonics present in its sound. The other reed instruments are conical in shape. The bassoon and the oboe are cylindrical on the outside, but they have conical bores on the inside. So all the harmonics are present in their sound. So, for reed instruments, the frequency equals n times the velocity over 4 times the length. Flutes, piccolos, and recorders act like pipes open at both ends, and therefore have all harmonics present. Therefore, the frequency equals n times the velocity over 2 times the length. Here are some demonstrations on flute and bassoon. Right, so first we just want to hear the sound of the mouthpiece by itself.
Okay.
And now let's put the rest of the flute onto the mouthpiece.
Okay.
Just start with all your fingers down so that we see all the holes are closed. Play a note. And then lift all your fingers up. All right, and then how did you make the 2 different notes?
My lips get tighter as I go up. For the low note, my lips are more relaxed and the air goes slower. And then air gets a little bit faster. A little bit faster and really fast. It's all in the air.
And then what special effects can we get out of the flute?
We can flutter tongue.
And what are you doing differently to make that sound?
Just rolling my R's, rolling my tongue.
Okay, and anything else?
We can sing. That's a piece by Ian Clark. I could do multiphonics.
Okay. And what are you doing to make those happen?
These alternate fingerings for C sharp and E, and D and F.
And then we're getting two notes at the same time.
Yes.
All
Can
right.
I make some funny sounds with this sound?
Sure.
Sounds like you're in Paris.
Right. Okay. All right, so let's start with show us the reed and show it sideways. All right, so there you can see it's two reeds that are held together. Let's hear the sound of the reed by itself. All right, now we're going to attach it to a tube, and let's see how that changes the sound of the reed. All right, and now let's put it there, and then if you could play your lowest note. If you can do just the scale all the way up, all the way up. All right, and how many octave range do you have on it?
3.5.
Which is more than most instruments
Right.
can do. And we're just going to watch as you just do it again, and we'll notice what's happening with the fingers as you start from low notes, where all the keys are pretty much covered
B
at
flat.
this point.
Right.
Now, you only really have like 10 fingers to do things with, so how do we get, we have a register key that allows us to change octaves?
We have practically 9 register keys here. This is all left thumb. And all these are our register keys, basically.
All right, so each time you play one, it brings it up. Does it bring up an octave or a fifth?
It doesn't really work that way. It just changes register. So in other words, if I was to play a low B flat, the next B flat doesn't require it, although we're just pushing a key down here. But the high B flat that I played before requires 2 of these thumb keys. So that, in essence, is an octave key.
Great.
So both keys.
Great. Is there any unusual techniques that you use? Are there any things that you do with the embouchure to change sound, or is it the
We can dip notes. We can go. We can also do a multiphonic. It's like a train sound. We can do stuff with the reed, not make a noise on the bassoon, like a helicopter noise, that kind of thing.
Yeah.
So multiphonics are usually the extended technique. We can do flutter tonguing. You know.
And so to do multiphonics, what are you doing?
So you can play. You're basically, I'm playing a low B flat, but leaving a key off in my right hand. So that creates. Here's a low B flat, and then a multiphonic on it is something like that. And I'm just lifting one key off, and that creates that sound.
Great. Thank you very much.
My pleasure.
Because the bassoon has such a large range, I thought it would be interesting to see how source filter theory plays a part in the timbre of the bassoon sound. Here's a spectrum of the bassoon reed playing by itself. There's a small tube that the reed is attached to called a bocal. Here's the spectrum of the reed after it's attached to the bocal. Notice that the peaks have shifted down in frequency and generally look more uniform. They appear to be harmonics of about 260 Hz. Now, after attaching the bocal to the bassoon, here's a spectrum of a low C played by a bassoon. Notice that the highest peaks happen at about 500 Hz, and the next peak of harmonics is about 1300 Hz, another around 1800 Hz, and another around 3000 Hz. Here's the spectrum of the next C. Notice that the harmonics are now spread further apart, multiples of 132 Hz rather than 66 Hz. But the peaks are still near 500, 1300, 1800, and 3000 Hz. Now let's look at C4. Now the harmonics are spread apart by increments of 262 Hz, but the peaks are still near 500, 1300, 1800, and 3000 Hz. This shows that even though the individual frequencies of the source are changing, the filter frequencies remain constant and are a large part of the timbre of the bassoon. When we start talking about speech, we will refer to these resonant peaks as formants. Now you're going to see a video of a scale being played by the bassoon. First, we're going to look at the individual frequencies, and then we're going to look at the envelope, the resonance peaks. You'll notice that even as the notes change, the resonant peaks still remain the same. To review, woodwind instruments are tubes with tone holes and a mouthpiece. They do not need to be made of wood. The sound source is an airstream blown across a mouthpiece or from pulses of air that are produced from a vibrating reed. To play different notes, woodwind instrumentalists press keys to cover tone holes, which change the effective length of the tube. Woodwind instruments tune by adjusting the mouthpiece to change the length of the tube. Temperature has a large effect on a wind instrument's tuning. Flute and recorder players change their airspeed to change octaves. Reed players use register or octave keys to change their registers. Reed instruments act like tubes closed at one end, so F equals NV over 4L. Flutes, piccolos, and recorders act like tubes open at both ends, so F equals NV over 2L.